Let's record this, why not? Okay. And so when I come up with my inequalities, perhaps in this case, it would be good to make a chart. I will go without a chart, okay? So I will just read and look at for my restrictions, okay? Even though I already gave you a hint. But it says here, when you start reading the cutting time and stitching time for each, right? You have at most 6 hours of cutting time, right? So I'm going to highlight that because that is a restriction. And I have 8 hours of stitching time. Due to popular demand, the manufacturer makes at least 20 soccer balls, right? So that's also another inequality. Create a system of inequalities and graph and state one possible solution. So I'm gonna address the cutting time. I have 8 hours, no, 6 hours. And the 6 hours, I know I'm going to have to go to minutes, but why don't I do that right away? 6 times 60 is 360 minutes. Okay, so I will go and get the cutting time for the first one, which is 1 minute. So 1 minute of cutting time for every football and 4 minutes of cutting time for every soccer ball that I make has to be less than or equal to 360. So now I have addressed, this is kind of my inequality number 1. Does that make sense? So you have to be careful. You have to kind of go and get your information and be very careful with that. Maybe have more than one highlighter. I don't know. Whatever you need to do to get that right. So stitching time. We have 8 hours available, right? So I will go 8 times 60, which is 480 minutes, right? Because I have to have everything in minutes or everything in hours. I tend to turn everything into minutes. So I will kind of write it next to it. So it's 2 minutes for stitching a football, and it's 3 minutes to stitch a soccer ball. And that has to be less than or equal to 480. So this, right, this kind of tells me how I came up with that, right? And this part tells me how I came up with that. And I need to make at least 20 soccer balls. So it's only specifically talking to soccer, at least 20 soccer balls. And when it's just the number of, that means that the soccer balls, which is y, has to be greater than or equal to 20. There's no x plus y, anything like that. This is specific just soccer balls, okay? And there you have it. That you should be able to graph, no problem, right? I think it's just the setup, right? It's this the hardest part right now. I mean, don't stop graphing, okay? I still want you to graph, but this part is the hardest part, right? It's probably half the battle, and then the rest is still work, but you can handle that, right? Is that good, Arlene? Yeah. Okay. So however you come up with these, that's up to you, right? Like how you want to organize your thoughts. Just make sure you get that. Okay. And maybe I'll just show you, right? If you go to on Google Classroom, right, the whole thing is worked out here. Still came up with the same 3 inequalities here, and I graphed it, right, and came up with the corner points. And all of the corner points end up being round values to begin with. Okay. And so any point inside the solution region is gonna be okay as a possible solution. Okay. Go ahead. All right, so now we have now focused on finding a possible solution. Starting today, we're going to start looking at finding the best solution. So it's out of the corner points, which is 2, 3, 4 points, right? We're going to narrow it down to just one, like the best one. And so we're not learning necessarily anything brand new. It's just one more layer to what we're doing. Okay, so I'm putting this away now. Continuing with my notes. Okay. Hold on. I'm going to go systems. Systems of inequalities involving optimization. The best answer. You're going to find the best answer moving forward. So far, we were able to graph the solution set for a system of inequalities and stated the POIs surrounding the solution polygon slash solution region. It's the same thing, but it's a new word, maybe solution polygon, because the solution region will look like a polygon and a triangle is also a polygon, right? So there it is. If the question asks for a combination that will maximize or minimize an outcome, it is essentially asking for you to find the best option from the points of intersection. So if it says that, hey, find a combination that will maximize profit or maximize revenue, right? Or maximize production. It could also be saying how can you minimize cost? How can you minimize the amount you're gonna have to spend for this project? They're asking you to find the best point out of the POIs, right? So you go all the way down to graphing it, finding your solution region, finding the points of intersection, and now we're gonna have to determine just one of those that is the winner. I call them the winner, right? Like the best one out of those, right? So so I'm just gonna add a little bit here to determine the optimal solution. And again, that just means the best answer. When somebody's trying to optimize something, you're trying to make it as efficient as possible. Okay? To determine the optimal solution, that's the best answer. We need an objective. I'm going to capitalize this. Objective function. Plugging in the POIs into the objective function will allow us to state the combination is best. So now we're going to run this through. I should say something about the objective function. I'm just reminded of something that happens quite often. Note, the objective function is not an inequality. Okay? And I will tell you what it looks like in a bit. The objective function is not an inequality. But it is drawn from the question. So sometimes parts of it will be, listen carefully, parts of it might be an inequality, but when you write your objective function, it will not be an inequality. It will not have a less than or equal to, greater than or equal to. Okay, let's, I'll give you a graph. So let's say this obviously would be a word problem because it's in quadrant 1. So just try your best to graph what I'm graphing here. The solution will be right in this, and I'm shading above everything. shading above the first line, and I'm shading above the second line. This point right here is 3, 2. This point right here is 0, 3. This point down here is 4.50. And the origin in this case is a solution as well because it's surrounding. Okay. Don't make it too fancy, okay? Just shade it. Given the objective function c is equal to 3x plus 2y, a, determine the combination that will maximize output. And so what we do is we state all of our corner points and plug it into this equation here. So we go 0, 0, right? That one is easy. C is equal to 3 times 0 plus 2 times 0, which is just 0. Obviously not going to win, right? That one. And then you grab your other corner point, plug that into your objective function. So it's 3 times 0 plus 2 times 3, because y is 3, right, at this point here. And so your answer is 6. No units in this case. Then you take 3, 2, plug that in. It's 3 times 3 plus 2 times 2. That's 9 and 4. That's 13. And then you have 4.5, 0. In this case, we don't know if it's a word problem or not, right? I mean, it could very well be because the graph is just in quadrant 1, but we don't really know if it's continuous or discrete. So we just keep it at 4.5. It's 3 times 4.5 plus 2 times 0. And that is 13.5. So that's basically what you will do at the end of a word problem. You take all the corner points, plug it into the objective function, and determine, right, which one, the greatest number is the greatest output, right? Max output. But what you will have to state is that a combination, right? So what I'm writing is a combination of 4.5 and 0 will result in max output. Just down the road, this will mean something, right? For 4.5 hours at job A and 0 hours at job B will result in the maximum income, right? There will be a context surrounding it. So you need to be prepared for that. So now I'll give you an actual word problem. maybe I will give you, I'll just give you a heads up here. No, I'll leave that for a bit later. Sorry. And the word problem is going to take all page, so I'm going to start at brand new page. If you want it all on one page, that's what I would suggest. Okay. So the problem is a parking lot has an area of 540 square meters of space available. A car needs 9 square meters to park safely, because you got to think, you got to come in, right? Have a little bit of space between the cars. So 9 square meters to park, while a bus requires 36 square meters. The manager of the lot does not want more than 45 vehicles at a time. The rates the parking fee, or the rate, is $7.50 per car and $25 per bus. Determine the combination that would maximize the profit. Profit, revenue, income, it's all the same thing, okay? So you need to just keep that in mind. Okay? So in this particular case, I want to highlight, when you read this question, I want you to think of, or really hone in on, the maximize profit. Okay? Maximize profit means, I'll use a different color, a red pen or something, right? That's what that means. So you can put an arrow going to that maximize. So what that means is only one corner point. Only one POI is the winner. Okay, so I'm assuming that most of you read it. It's like, yeah, this is an inequality for sure, right? We have the at least, at most, all that. But now we're taking it, this is kind of like the last step in this unit, optimization, right? Go ahead. So let's get started. Just like before, okay? X number of cars. Okay. Y is the number of buses. We will state that X and Y has to be greater than or equal to 0. Only positive values apply. And I will make a note that this is discrete data. So that would be worth 1 mark, more or less, on a test, right? And then there's, now I'm going to grab my yellow highlighter, right? The lot has 540 square meters of space. So that is an inequality, right? I keep reading, there's 9 square meters for the car and the bus requires 36, but that doesn't give me an inequality. The manager of the lot does not want more than 45 vehicles. Basically, no more than 45 vehicles. If you want to do this, I'm grabbing my red pen and I'm just going IQ1 on top of the first highlighted section, and I'm going IQ2 right next to this section here that I highlighted. So 2 inequalities. And then keep reading. The parking fee is $7.50 per car and $25 per bus. But is there any restriction on money, on profit? It's not saying wants to make at least this much, any of that. So these coefficients, you will wait for now. You won't use them, okay? So let's go ahead and come up with our inequalities. So we have that we need 9 square meters for every car, and we need 36 for every bus. And that has to be less than or equal to 540, right? All in square meters, we're great, we're doing great. And then the next one is saying no more than 45 vehicles at a time, right? So the number of cars and buses has to be less than or equal to 45. Okay, so you can put down here 540 square meters available, and then maximum of 45 vehicles. Okay, so if you go back to your notes, like, okay, that's where I got that from. Okay, so let's go ahead and graph these things. So I will just go ahead and do that right next. 9x plus 36. Y is less than 540. I will come up with my x-intercepts and the y-intercept. Okay, so that's 9x is equal to 540. Both by 9. Mental math, 60, right? That's 60, 0. And then we have 36. Y is equal to 540. Divide both of them by 36. That gets you 15. So 0, 15. I have both intercepts. Then I rewrite. And the 9x comes over subtracting. The 540 is already there. Divide everything by 36. Remember that when you divide by negative, the inequality flips, right? You remember that? It's not happening for a while because we're doing word problems, but don't forget about it, right? So y is less than or equal to. You can reduce it or just leave it. It's up to you. You can leave it negative 9 over 36. It'll be just fine. So that's solid. True is below. You shade above. Right? As soon as it's a system, we want to do reverse shading. And the other one is so easy. We love those. 45, 0, 0, 45. Rewrite it. And this is solid. True is below. Shade above. Same as the one before. I will type this into my calculator before I graph, just to make sure the point of intersection shows up and I know where it is. Make sure you get those negatives right. So I type that in. Don't forget about the variable x, right? Actually typing that in, or else you get a horizontal line. Or worse yet, if you multiply, then you won't even notice. And my window here, I need to raise my y max a little bit on the window. Yeah, I don't know if some of you did read the post that I made, right? There's that setting that you can change to make it a lot faster. So I'm gonna change my y min to like -5 only. I don't want to see too much below. Okay, so I need to find that intersection, second trace 5, enter, enter, enter. So it's 45, right? So we got that. That should be pretty good. So I'm just going to keep that in mind. So grab your rulers. I'm going to try to make this graph fit right here. So label first, okay? Arrows and labels. So down here we have number of cars. Number of buses. Now my scaling, I need to go 60 for sure, up to 60 on my x-axis, and my y-axis up to 45. So I'm going to go 10, 20, 30, 40, 50, 60, 70. I keep going, right? That's plenty of room there. And if I go 10, 20, 30, no, that's too much here. So I have to go 10 at a time here, or else it won't work for me. my particular scale has to be like that. So 60, 0, 0, 15 would be right about here. Graph it. 45. 45 is right there. Make sure it's where it's supposed to be on the grid. And now I'm going to label here. This one is y is less than or equal to negative x plus 45. This one is y is less than or equal to negative 1/4 x plus 15. And both of them are shaded above. So if you have your ruler, it's probably a good idea to place it there and then just start shading above that one. And you take the other one as well and you shade everything above that one, which gets rid of this little triangle here. There you go. So my solution region is here. You label that, right? And I'm going to state the corner points or the POIs. I'm going to state them side by side, okay? Is 0, 0 a POI? Yes, it is. Comma. This one is 0, 15. Comma. Down here is 45. 0, comma. This one we just found here, right? That one was 45. I'm going to just make a note that I used the calculator for that one. All of this just to show you, like this part right here is really what today was all about, this last part. What would be the objective function in this case? And I will call that P for profit. How would you figure out what combo would give you the most money? Well, remember the coefficients that I talked about earlier, the 750 and the 25? Remember those? Now they show up because they will tell us how much money you will make, right? So it's 750 for every car, and now the calculator thing there is in the way. So I'm just going to plot it up here. Plus $25 for every car. This is your objective function, folks. Okay, which I usually come up with it once I found all my corner points. I ask myself, what is the question asking for? Oh, profit. You can actually do this, folks. Go back in here and just put dollars there. Dollar and dollar. Because this is going to tell us how much money we make in each of these cases. So 0, 0, this is very irrelevant, I know. Do it anyways. $0. If there's no cars, you don't make money. Easy as that. 0, 15, you take your objective function. It's 750 times 0 plus 25 times 15. I will park it there for now, and I'll just keep doing that for all of my corner points. You plug that in, and so you get 750 times 45 plus $25 times 0, no buses, and The last one is 45. My profit is 750 times 40 plus 25 times 5. And because you have awesome calculators, not all grade 11 classes get these, just so you know, so you're lucky. Okay, it's usually grade 12s. So basically just type this in, right? This is just 25 times 15. That's 375 that I get there, right, for the first one. So you make $375 in this particular instance. And you go back and you just go 750 times 45. And that gives you 337.50. And then the last one, it's 750 times 40 plus 25 times 5. You can type it in all in one shot. And you get 425 there. Exactly. You circle it because that will maximize the output, but you have to answer as follows. Okay? Allowing 40 cars and 5 buses will maximize profit. Okay? This is basically today's main focus, is this part right here. Like this whole thing right here is new, right? Can you wrap your head around that?
Yes.
Absolutely, 100%. Aaron, I hear some sarcasm there. No, are you good? Yeah? Okay, hold on. Hold on. Okay, one more thing. Here. Homework. You can tell that for this unit, there's a lot of booklet stuff, okay? Because the textbook, not good. Not very good. Once you do quadratics and stuff, we'll do more. Quadratics, you heard right. Here, just do page 18. There's a bunch of questions there. Yeah, I'll just do that. Plus page 15. 15 is just one graph, and I'll show you what 15 looks like. There's no context here. So all 4 quadrants are going to be included. Okay? So answer key, I have it all queued up to post.